Welcome to the next exciting adventure of 5-2. It's not that exciting, really. Okay, this is 5-2 Part B, and you're very quickly going to realize why I needed to make this into two parts, because there's a lot in just 25 through 36. There's a lot of work, so let's get started. We don't have all day. Okay, so the first ones, we're starting on page 304, okay, in your workbook. 304, I don't know if you could see that if it's behind that thing. 304 in your workbook, problem number 25. Write an equation in slope-intercept form for the line that passes through the given point and is parallel to the graph of the equation. Then, write an equation for the line that passes through the given point and is perpendicular to the graph of the equation. So, to review, I need to remind you that parallel lines have the same slope. And perpendicular lines, I'm not going to be able to fit that whole word on there, am I? Oh, I got it. Have negative reciprocal slopes. Negative reciprocal slopes. All right, so when we're looking at number 25 here, we know we have a line that passes through this point, but we need to know what our slope is. Well, our slope, because the first problem we're doing is we want a slope of a line that's parallel to this one, it means it will have the same slope as this one. This is written in slope-intercept form, so I know that the slope is the number in front of x. So in this case, slope is 1, positive 1. Okay, so to find the parallel line, I use y equals mx plus b. I use this for x, this for y, and this for m. Okay, so y is negative 2, m is 1, x is 3, and I need to find b. Negative 2 equals 1 times 3 is 3, plus b. Get b by itself, I subtract 3 from both sides. That gives me negative 5 equals b. So the equation of the line that is parallel to this one is y equals, now I would write 1x, but you know Reveal is not going to want to have a 1 there, so I'm just going to write x minus 5, okay? Because the y-intercept was negative 5, and it's parallel because it has the same slope as this line, all right? Notice the y-intercepts are different, all right? It's you know, they're going to be staggered, so, but they are going to have the same slope. Now, to find the line perpendicular to this, I need the negative reciprocal. Well, if you think of this slope as 1 over 1, the negative reciprocal of that would be negative 1 over 1, or just negative 1, okay? Which is the same as negative 1 over 1. Kind of a bad example for the first one, you know, when you're trying to teach negative reciprocal, 1 is such an oddball. It'll be more obvious on the next one. And it's still going to pass through the same point, though. 3, negative 2. All right, so we do it again. We do y equals mx plus b. We use negative 1 for m, 3 for x, and negative 2 for y. So negative 2 equals, nope, that's, the slope goes there. Nope, 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 nope. Okay, slope is negative 1 times the x-coordinate, which is 3, plus b. So it gives us negative 2 equals negative 3 plus b, because negative 1 times 3. And then we add 3 to both sides, which gives us b is 1. So the equation for the perpendicular line, I'm not writing that word again, no. We're going to go to para and perp. Not doing ain't nobody got time for that. The slope of this line was negative 1, so we're going to have negative x, and the y-intercept is positive 1, so it's negative x plus 1. So that's the line that would be parallel to it. This is the line that would be perpendicular to it. It's freezing in my classroom. I should have brought a cardigan today. Okay, so we do it again. Our slope of the parallel line will be the same as this one. So the slope of the parallel line would be 3. The slope of the perpendicular line will be negative 1/3. Okay, we think of a slope of 3 as 3 over 1, and then to go perpendicular, you flip those and you change the sign, so you would have negative 1 over 3. Okay, all right, so we do this again. Y equals mx plus b. This is y, negative 3, equals, the slope is 3, and the x coordinate is 4. Okay. Negative 3 equals 12 plus b. And then we subtract 12 from both sides, and we get negative 15 is b. So here's our slope. Here's our y-intercept. The equation for the parallel line would be 3x minus 15. Okay. So that's the parallel one. I told you I'm going with para and perp. The perpendicular line would have a slope of negative 1/3, but would also pass through the point for negative 3. That's the stipulation of the problem. So using y equals mx plus b, y is negative 3, m is negative 1/3, x is 4 plus b. Negative 3 equals, this would be negative 4/3 plus b. And then I need to add 4/3 to both sides. All right, well, 4/3 is 1 1/3, and if I took 1 1/3 away from 3, that would give me 1 2/3. So negative 1 2/3 equals b. Did I do that right? I want to make sure I'm telling you the right answer. Yeah, that's right. So the equation for the perpendicular line, the perp, would be y equals negative 1/3 x minus 1 2/3. Now, heads up, I'm having issues with reveal. If you put this answer in like this, it's going to choke on it. All right. Now, I am hand grading these, so I would eventually mark it right, but reveal will count it wrong in the beginning. Here's the reason. First of all, reveal does not like that negative to be attached to either one of these numbers. It likes it to be out in front. Also, it doesn't like you using mixed numbers with fractions. It wants to be all fractions or all mixed numbers. I don't know. It's somebody got lazy entering correct answers in the program. Let's do some more of this, though. This is super fun. We're having a good time. Okay, so same directions. We want the parallel one, and we want the perpendicular one. Okay. Parallel will pass through the point 0, 2, and would have a slope of negative 5. All right, so we would have y equals m, negative 5, times x plus b. Okay, the perpendicular slope would be positive 1/5. Remember, you flip it over, so this is like 5 over 1, so we flip it over, and you change the sign. If the first one's negative, second one's positive. First one's positive, second one's negative. You know what? I'm going to move where this camera thingy is because I'm covering up my page numbers. Okay, back where I was. Negative 5 times 0 is 0. So this is a shortcut here, right here, because that's going to be 0, so b is 2. So our equation for our parallel line would be y equals, the slope is negative 5x plus 2. That's our parallel line. The perpendicular line, we would substitute 2 for y, 1/5 for m, 0 for x, plus b. All right? We get again 2 equals b. All right, so the perpendicular line would be y equals 1/5 x, and it would still be plus 2. That would be perpendicular. I just want to double check and make sure I'm telling you the right answer and then I'm not messing this up. Nope, those are right. Okay, as you know, I can and will make mistakes. All right, the parallel line for this one will have a slope of negative 1/2. The perpendicular version of this one will have a slope of positive 2, which is really 2 over 1. So here's our x, here's our y. Y equals slope times x plus b. Now, negative 1/2 times negative 4 is positive 2. So it would be half of 4 and a negative times a negative. Subtract 2 from both sides, and we get that b is 0. So the way you're going to want to type this equation in is y equals, remember to put the negative sign out in front of the fraction, 1/2 x, and don't put plus 0 here. We don't write the plus 0. Perpendicular line has y equals mx plus b, y equals m, the slope is 2 in this case, x is negative 4 plus b. 2 equals negative 8 plus b. Add 8 to both sides, and we get that b in this case will be 10. So the equation of the perpendicular line is y equals 2x plus 10. And you can tell they're perpendicular because their slopes are negative reciprocals of each other. Two more like these, and then we'll switch to do something different. All right, the parallel line has a slope of negative 3/4, and the perpendicular line has a slope of positive 4/3. Negative reciprocals. Okay. So using y equals mx plus b, we have y equals m times x plus b. And negative 3/4 times negative 2 is positive 6/4 or 3/2, reducing that, plus b. And then we subtract.
We have 8th grade students.
That scared me.
For the second session. 8th grade students to the auditorium. Second session. Thank you.
Nothing weird going on here. Subtract 3/2 from both sides. 3/2 is 1/2. If you take 1/2 away from 3, you get 1/2 equals b. All right, so our parallel line equation is y equals, the slope is negative 3/4, x plus 1/2. That's the parallel. The perpendicular one, we would have y equals m x plus b. Okay. And negative 2 times that would be negative 8/3 plus b. And we're going to add 8/3 to both sides. But 8/3 is really 2 2/3, so I'm going to write it 2 2/3 because that will be much easier to add to 3, which gives us 5 2/3. Not a very pretty y-intercept, but okay. So the perpendicular line has an equation of y equals 4/3 x plus 5 2/3. Now, a good way to check your work on this would be to go to Desmos Graphing Calculator and enter both of these equations and see that that this one is parallel. You could enter all three of them. Actually, you could enter the original equation and then this one, and you'll see that they're parallel. And then you could enter this equation, and you'll see that it's perpendicular. And then you'll have parallels cut by transverse. Well, yeah, you would. Pretty cool. Okay, so our last example like this, the parallel line will have a slope of 13. The perpendicular line has a slope of, get this, negative 1/13. That's just nasty. All right, and this is our x and this is our y. So y equals m times x, I'm going to need a calculator, plus b. Let me get a calculator. I didn't have this one worked out in advance. I don't know my 13s. 13 times 9. Okay, so then we have 12 equals 117 plus b. To get b by itself, we subtract 117 from both sides. 117 minus 12 would be negative 105. Not want to graph that one. So the equation of this line would be y equals 13x minus 105. And that would be parallel to the original equation. Perpendicular, well, y equals mx plus b. Well, this would be negative 9/13. Not getting any prettier, is it? And then we add 9/13 to both sides. And we get 12 and 9/13 for b. Oh, heavens. Okay. So our equation would be y equals negative 1/13 x plus 12 and 9/13. Well, I'm telling you what, you'll be thinking you got that wrong, right? But, yeah, no, it's right. It's just that ugly. All right, so now we're going to switch gears, though, and do something a little different. With this next group of problems, it wants you to tell, are the equations parallel, perpendicular, or neither? Okay, the problem is they're not, you need them both in slope-intercept form to be able to, easily compare them, and these are not both in slope-intercept form. So the first thing you want to do is fix this one. This one's in slope-intercept form, but this one's not. So the first thing I'm going to do is subtract 4x from both sides. That gives me y equals negative 4x plus 3. So I'm comparing this equation with this equation. Are they parallel, perpendicular, or neither? They're trying to trick you here. A slope of 4 and a slope of negative 4 are not negative reciprocals. This would have had to be negative 1/4 for these to be perpendicular. And they're not parallel because 4 and negative 4 aren't even going the same way. All right? This is puff, puff, positive. This is nice, negative. No. So those are neither. Let's check out these two. Same thing. This one's not in slope-intercept form, so I'm going to fix it. Y equals negative 2x plus 3. All right. And this is a slope of negative 2x. This is a slope of negative 2x. Because the slopes are the same, the lines will be parallel. These aren't as much work. Except for now, you've got two of them, and neither one of them is in slope-intercept form. So 3x plus 5y equals 10. I want to get y by itself. Subtract 3x from both sides. That gives me 5y equals negative 3x plus 10. Divide everything by 5. And I get y equals negative 3/5 x plus 2. The other equation, 5x minus 3y equals negative 6. Subtract 5x from both sides. I get negative 3y equals negative 5x minus 6. Then divide everything by a negative 3. And that gives me y equals positive 5/3 x plus 2. Now, comparing the slopes, see that these are negative reciprocals of each other, so these two lines would be perpendicular. I said I wasn't going to write that word again, didn't I? So, why are you not cooperating with me? I want to change to blue. Okay. Again, neither one of these is in slope-intercept form. Negative 3x plus 4y equals 8. And negative 4x plus 3y equals negative 6. Okay. I want to get y by itself, so I'm going to add 3x to both sides here. That gives me 4y equals 3x plus 8. Divide everything by 4. That gives me y equals 3/4 x plus 2. Over here, I add 4x to both sides. And that gives me 3y on the left, 4x minus 6 on the right. Then I divide everything by 3. And that gives me y equals 4/3 x minus 2. Now, I'm going to go back and double check and make sure I did this right, because these look like they want to be perpendicular, but they're not negative reciprocals of each other. They're just reciprocals. So checking to make sure I did this right. Yep, these are neither. Because they are reciprocals, but they have to be negative reciprocals to be perpendicular. Okay, and I think these are my last two examples. Again, they're not in slope-intercept form. So we have 2x plus 5y equals 15. If you want, it might be a good idea for you to go ahead and pause the video and attempt these on your own, and then come back and watch me do them and see if we get the same answer. How about that? You could do that if you want to pause it. Otherwise, I'm going to keep going, though. I'm going to subtract 2x from both sides. That gives me 5y equals negative 2x plus 15. Divide everything by 5. And it gives me y equals negative 2/5 x plus 3. Over here, subtract 3x from both sides. Gives me 5y equals negative 3x plus 15. Divide everything by 5. And that gives me y equals negative 3/5 x plus 3. Neither. Again. Yep, those slopes do not match, and they're not negative reciprocals of each other. All right, let's see if we get it. Something interesting on this one. 2x plus 7y equals negative 35. And 4x plus 14y equals negative 42. Subtract 2x from both sides. Gives me 7y is equal to negative 2x minus 35. Divide everything by 7. And I get y equals negative 2/7 x minus 5. Over here, subtract 4x from both sides. It gives me 14y equals negative 4x minus 42. Divide everything by 14. Gives me y equals negative 2/7 x minus 3. These lines are parallel because they have the same slope. Okay, well, that was super fun. I don't think I have any more problems for you. I don't. So go on over to McGraw-Hill and complete practice part B. Have a great time with that. We'll do the quiz tomorrow, and I'll see you in the library.